Behind this highly secured door in an ASML cleanroom, there's a giant $400 million machine.
It's bigger than a double-decker bus.
The most advanced machine tool in history.
I would say it's been a very risky investment because when we started, well, there was no guarantee the technology will work.
Texas Instruments is making a big bet that companies will want to make a lot of chips on U.S. soil, amidst Trump's new promise of a 100% tariff on chips from companies that are not making in the U.S.
The whole campus is going to be bigger than 70 football fields or 2 Empire State Buildings laid side by side.
This is the iPhone Air. Apple's most advanced chip yet, the brand new A19 Pro, is inside both the Air and the 17 Pro.
So why did the company's stock dip on the big reveal?
All right, we're about to enter
The high-NA lab.
Behind this highly secured door in an ASML cleanroom, there's a giant $400 million machine.
It's bigger than a double-decker bus.
Made with such closely protected technical specificity,
Very complex. The most advanced machine tool in history.
that no filming's ever been allowed, even by ASML's own team, until we flew across the world to see it.
We're here at ASML's headquarters in the Netherlands, where 100% of the world's extreme ultraviolet lithography machines are made, and now the next generation machines called high-NA. We had to wear these bunny suits to protect these extremely precise machines from getting contaminated by our own hair and skin cells.
This is high numerical aperture, high-NA, the new generation of EUV machines, the only machines in the world capable of printing nanoscopic blueprints onto the most advanced chips. Nvidia, Apple, Taiwan Semiconductor, Samsung, Intel, none of their advanced chips can be made without EUV.
And this company has that market completely cornered.
The first high-NA machine was installed in the US at Intel's Oregon Chip Fabrication Plant, or fab, last year. Only 5 have ever been shipped.
Indeed, the machine is so big you can't ship them in once, so we break them into parts.
Now they're being ramped up to make millions of chips on the factory floors of the few companies that can afford them: Intel, TSMC, and Samsung. ASML says eventually high-NA will be used by all its EUV customers, other advanced chip makers like Micron, SK Hynix, and Rapidus.
Without EUV, without very advanced logic manufacturing, most probably AI cannot happen.
CNBC went from ASML's labs in California all the way to its Veldhoven, Netherlands headquarters to bring you this never-before-seen look at the world's most advanced chip-making machine, and to ask its makers exactly how it works and what could go wrong amidst Trump's tariffs, export controls, and a new training facility coming to the U.S. Suited up and through an air shower,
It's basically to blow off all the contamination from your suit and your clothes.
down several long hallways where humongous parts are being meticulously moved,
How many people would you say are working here 24/7?
Inside the EUV factory alone, it's like 2,000 people. It's a 24/7 operation.
Essia Hadou took us to the restricted lab space where 40 years of ASML's technology research all comes together.
It takes approximately a year and a half to create this system.
Hadou leads the team that tests and qualifies the high-NA machines here.
It still does blow my mind. I think even if you learn more about it, it blows your mind even more.
The big machine, at the end of the day, is used to transfer a pattern, which we store on a mask, onto a wafer. And then at the end of the day, you cut them in pieces, you package them, and then you end up in your phone.
Joost Benschop joined Dutch electronics giant Philips in 1984. 2 weeks later, ASML was founded as a subsidiary, conducting research out of a leaky shed nearby in Eindhoven. It broke off from Philips with an IPO in 1995, and 2 years later, Benschop helped spearhead ASML's first foray into EUV.
3-4 years later, we had enough confidence to put all our eggs in one basket called EUV. With hindsight, we can say we placed the right bet.
On a yearly basis, I think we file several hundreds of patents on EUV.
Christophe Fouquet began as CEO just over a year ago, but he's been with ASML more than 17 years.
We barely made it. I think sometimes people forget that, but EUV took us practically more than 20 years. I would say it's been a very risky investment because when we started, well, there was no guarantee the technology will work.
By 2018, ASML had shown that EUV was possible, and it's the same process used in High-NA. Here's how it works. Chips are built in a grid formation on thinly sliced wafers of silicon, each with up to 100 thin layers that make up billions of transistors that determine what the chips can do. These layers are printed using lithography, extremely precise rays of light projected through a mask of the chip design until they hit the surface of the wafer that's been coated with photoresist chemicals. ASML's older generation DUV machines, which it still makes, use rays of deep ultraviolet light with a wavelength of 193 nanometers. Nikon and Canon in Japan are still competitors in DUV. But ASML's real breakthrough came with that bold bet on a technology many thought was impossible, using even shorter wavelength extreme ultraviolet light, EUV, something that to this day no other company does.
A few more people tried for many years, but the size of the investment, the commitment you have to have, I think discouraged quite a few people.
Transistors have gotten so small, down to 10,000 times thinner than a human hair, that ASML decided to create its own source of smaller, more precise EUV light. At a wavelength of 13.5 nanometers, it's the width of just 5 DNA strands laid side by side.
So small that it gets absorbed by almost everything, and that's why this whole system needs to be in a vacuum.
This tiny thread may look like the strand of a spiderweb, but it's actually molten tin being shot out at 50,000 droplets a second. The tin droplets are vaporized with a laser, and those tiny explosions are what emit photons of EUV light.
This is called a CO2 laser. It's been used in the car industry for many years. They would cut through steel with one of these. We use 4 of them to shoot at one of these tiny tin droplets to generate a plasma which is hotter than the sun. That plasma generates EUV, and that EUV is captured by this collector mirror that comes from Carl Zeiss and brings the light into our scanner.
The light bounces off of mirrors that aim it through the lens, much like how a camera works. But because EUV gets absorbed by typical mirrors, German optics company Zeiss made specific mirrors just for ASML that are the flattest man-made surfaces in the world.
And then the light is emitted through the projection optics onto the wafer, which is about here. So this is the wafer table.
When the EUV finally hits photoresist chemicals on the surface of the silicon wafer, it prints the minuscule blueprint that makes up the chip. The aim needs to be so precise, TSMC says it's equivalent to shining a laser from the moon to hit a coin on the Earth. EUV made up less than 8% of ASML's total number of machines sold in 2024, 44 EUV machines versus 374 cheaper DUV machines. But with a price tag of $220 million, EUV made up 38% of ASML's system sales revenue.
But the cost of the chips the tool is going to create is going down.
Because you're the only company in the world that makes these machines, what's stopping you from setting the price even higher?
Well, what stops us is Moore's law says that we need to continue to drive costs down. This allows you to go to the next node, and then the next node, and then again the next node. If this was to stop, then everyone gets stuck.
ASML began developing its latest $400 million High-NA machines around 2016. Inside, all the same processes still happen with the same EUV light source, but there's one key difference.
We increase the aperture of the opening angle of the lens.
High-NA stands for high numerical aperture, meaning it has a larger lens opening, increasing the angle at which the light is captured by the mirrors. More light coming in from steeper angles allows High-NA machines to capture increasingly small designs on chip masks, so they can be projected in one exposure step, whereas original lower NA machines reach higher resolution to project these tiny designs using multiple exposures through multiple masks.
1 become 2, then 2 become 3, 3 become 4. And when the number increases, it gets very complex process-wise, and the yield goes down.
But with a higher NA, resolution improves, and the small designs can be printed with fewer masks, saving time and money.
The larger the number, the smaller the thing you can print.
But this higher NA also comes with a much higher price tag for one main reason.
The higher the NA of an optic, the bigger the mirror you have to use, and therefore the bigger the system.
These machines also take up a huge amount of power.
How much power do these machines take?
I think they take too much. If we don't improve the power efficiency of our AI chips over time, the training of the models could consume the entire worldwide energy. And that could happen around 2035. Since the moment we started EUV, 2018, we have reduced the power, the energy needed per wafer exposure by more than 60%.
ASML says its machines print about 200 wafers per hour, 24/7, 365. The goal is several hundred per hour.
You can print, at the end of the day, millions of these wafers per year.
At a conference in February, Intel said it started making chips with High-NA, using it for some 30,000 wafers so far, and that it's about twice as reliable as previous models. And Samsung said High-NA could reduce its cycle time by 60%.
High-NA means two things. First and foremost, shrink, so there's more devices on a single wafer. And secondly, by avoiding multiple patterning, you can make them faster and you can make them with higher yield.
In reality, every chip is made using multiple different lithography techniques at different resolutions.
Every chip consists out of like 100 different layers. Most of the layers are actually made with deep UV, which is a much smaller system.
Legacy DUV machines sell for less, $5 million to $90 million, but still make up over half of ASML's sales.
The older machines are in high demand. Many of the chips we use in our daily life do not require EUV. If you press the button to open the window in your car, unlikely an EUV-based chip is needed.
Turns out ASML sells a lot of its legacy machines to China, although US export controls prevent it from selling EUV there. It's a ban that started under the first Trump administration.
The Trump administration is very focused on ensuring that China does not get access to the most advanced tools and chips that are required to power AI.
So without access to ASML's EUV machines, could China develop its own?
I feel like it's a real long shot that China could enter this space. But right now, China's really figuring out ways to take things like 7 nanometer, the most advanced nodes that can be done without EUV, and figuring out ways to scale them. And they've been able to do that successfully in some areas, like in smartphones and personal devices.
Still, export controls haven't stopped China from stockpiling ASML's less advanced machines.
At one point recently, up to 49% of your business was in China. What happened there, and what is that number at now?
We had a huge backlog in China because we got order in 2022 at the peak of the market. And in 2023-24, the rest of the world kind of went down. So basically, we could use our capacity to fulfill this backlog. End of 24, last quarter, the part of China in our business went down to 30%.
US concern over advanced tech making its way to China has accelerated amidst the generative AI race. But that boom has also sent demand for chips and the machines that make them soaring, and with it, chip stocks, including ASML's, which hit an all-time high in July. Still, it's declined some since as the chip industry faces uncertainties, chief among them, Trump's tariffs.
Any idea how tariffs are going to impact ASML?
Well, the short answer is I don't know, we don't know, and if anybody would know, you could make a lot of money, but we don't.
In its first quarter earnings reported last month, ASML missed on order expectations amid tariff uncertainty.
I suspect ASML will come in and advocate for a very low to minimal to no tariff on their machines.
The impact of tariffs is complicated by ASML's complex web of 800 global suppliers and the winding worldwide path ASML's machines take before arriving in a fab. Each High-NA machine is made up of 4 subsystems, manufactured in Connecticut, Germany, the Netherlands, and California. Each module is shipped separately to ASML's headquarters in Veldhoven, where they're put together, tested, then disassembled again, bound for fabs in places like the US or, more frequently, Asia.
How do you ship something this massive?
Yeah, it takes about 7 Boeing 747s to ship this whole thing, and it's about 25 to 30 trucks.
For years, Asia has made up more than 80% of ASML's business. But the US share, around 17% in 2024, is growing fast, especially as Intel builds new chip fabs in Ohio and Arizona, and TSMC is now in volume production in Arizona too.
So there's a lot of chip customer in the US. So there's I would say, a good reason to have chip manufacturing.
When we first got a look at EUV in 2022, ASML had about 32,000 employees. Today, that number's grown to 44,000, and 8,500 of them are in the US, like Eric Ma, who's been with ASML in San Jose, California for 18 plus years.
Have you gotten to see the High-NA machines?
Yes.
What is it like?
Oh, it's a huge.
Of ASML's 60 global offices, 18 of them are in the US, including a manufacturing site in Connecticut and R&D sites in San Diego and here in San Jose.
We're here at ASML's Silicon Valley, California location, and behind me is a metrology machine. This one has 25 beams of electrons that are used to test the different microchips to make sure that the yield is going to be good.
For High-NA in the US, it's likely that Arizona could be a major hub. Many of ASML's first High-NA shipments went to Intel last year, and the struggling US-based chipmaker is building a giant new chip fab in Chandler, Arizona.
Intel has been, for many years, a formidable partner for ASML. We're the first company to believe in EUV and the first company to work with us to develop EUV. They have done the same on High-NA. And I think that moving forward, the role of Intel for the US autonomy, independence on semiconductor is still very critical.
But TSMC is far ahead of Intel in advancing chip nodes. We recently visited TSMC's new fab north of Phoenix, the most advanced chip fab on US soil. The need for High-NA there will likely come soon, with ASML's original EUV machines in use now.
In order to hook one up requires something over 2,000 electrical connections, over 2 kilometers of cabling, 100,000 parts, 40,000 bolts. We're talking about massive.
With so many EUV machines in Arizona, ASML is, for the first time, bringing a training facility to the US. Its only other training centers are in the Netherlands, Taiwan, and Korea.
We're planning to open that in the next few months in Arizona with the idea that we could train 1,200 people every year on EUV, DUV.
As chipmaking shows no signs of slowing in the US or elsewhere, ASML is already hard at work on its next generation machine, Hyper-NA.
With an even larger NA that can print even smaller features.
I heard it could be up to $700 million. Do you have any price?
Oh, it's way too early to mention the number, but typically price goes up. So no, I don't think it's going to be that high.
Despite market headwinds, Fouquet told CNBC that customers will need Hyper-NA within 10 years.
Anything you can tell us about Hyper-NA? How far away are we from seeing that?
For us, it's not necessarily a difficult product. We need our customer to need it as well. And if you look at the roadmap of our customer, I think the need for Hyper-NA will be somewhere between 2032 and 2035.
But for now, ASML is focused on meeting demand for High-NA. It plans to ship at least 5 more systems this year, ramping to a production capacity of 20 machines in a few years.
While this is a monopoly right here and today, in the era of AI, there will be new vehicles for building semiconductors. And if I'm ASML or from any other company in this space, I'm being careful to make sure that I'm protecting my position, not just in the near term, but in the long term as well.
Rising up out of sprawling ranch land in North Texas, there's 2 giant new buildings.
The first one in the distance is an operating clean room. The one closer to us is the second factory that today is a shell.
And they're just the start of Texas Instruments' $60 billion 7-plant project, officially announced in July.
Yeah, this site long-term will produce hundreds of millions of chips every day.
Texas Instruments is making a big bet that companies will want to make a lot of chips on U.S. soil. And in August, Apple made a big new commitment to do, in part, just that. Amidst Trump's new promise of a 100% tariff on chips from companies that are not making in the U.S.
Apple is leading the creation of an end-to-end silicon supply chain right here in America. In Texas, we're working with manufacturers like Texas Instruments, Global Wafers America, and Applied Materials.
Apple has committed to making critical foundational chips for iPhones and other devices at TI's new fabs, and to supporting tool installations to make it happen, something we got to see in action in Sherman, Texas.
We are the first ever media to get inside this massive factory in North Texas. The whole campus is going to be bigger than 70 football fields or 2 Empire State Buildings laid side by side.
Though Texas Instruments doesn't make the world's most advanced chips, championed by the likes of TSMC and Samsung, its essential components are everywhere, in smartphones, cars, and data centers powering generative AI, with big customers like Nvidia, Ford, Medtronic, and SpaceX. Still, in July, TI shares plummeted amidst tariff concerns after its latest earnings report, although they've bounced back some since.
The worry is their end customers, like in the wake of tariff uncertainty, they don't know what to expect. Are they stockpiling?
Which has some asking, will future demand be strong enough for TI's huge spend to pay off? It's building 4 fabs here in Sherman, 1 outside Dallas, and 2 in Lehigh, Utah.
We would have more than 5x of the capacity that we have today when all of these fabs build out.
5x is a lot. Do you think the market is going to need all that?
Yeah, when you think about the semiconductor content growth, it continues to grow.
We went to Sherman for this never-before-seen look inside Texas Instruments' newest fab, and to ask top leaders why, despite tariffs and decreased market share, this huge investment makes sense now. When we first visited the Sherman fab, SM1, 2 years ago, it was just a concrete shell.
We're standing under the waffle table. That's what it's commonly called. So it's a clean room up top. The air comes through.
Now it's fully built. So we had to gown up in bunny suits to enter the operational fab, protecting the ultra-precise chip-making process from our hair and skin particles.
So as the wafers come out of the little box, they're going into a very clean environment within each tool. There's over 15 miles of this automated track.
Mike Haggerty has been with TI for 16 years. He showed us different tools and steps in the chip-making process.
The equivalent in this room is called CMP, for chemical mechanical polish.
SM1 is currently in qualification, testing everything out before entering full production by the end of the year.
These tools are how our design become a reality on a wafer.
And how many wafers are going through here, like let's say in the 10 minutes we've been standing here?
These tools are very fast. They're processing hundreds of wafers every hour.
TI was originally founded in 1930 as Geophysical Service Incorporated for oil exploration and later military electronics. In 1951, it was reimagined by 4 Dallas engineers and given its new name, Texas Instruments.
Texas Instruments is not just the company that makes your graphing calculators. It's actually responsible for the first ever integrated circuit more than 60 years ago.
While TI does still make its ubiquitous graphing calculators, its defining moment came in 1958 when TI engineer Jack Kilby filed the first patent for an integrated circuit. It paved the way for miniaturizing chips by building all the components of a circuit, not just the transistors, directly into a single piece of silicon.
And it's helped spawn really a pretty large industry and the electronics that we carry today.
With TI for 24 years, Mohammed Yunus now runs technology development and global manufacturing. Unlike the costly, bleeding-edge 2 and 3 nanometer chips being pioneered by TSMC and Samsung, Yunus says TI's core business, analog and embedded chips, are made on cheaper legacy nodes, 45 to 130 nanometer.
Which we believe is the sweet spot for analog and embedded because they provide the right performance, the power, the voltage that our portfolio needs.
Analog chips process signals from the real world, like sound, light, and pressure. Think the temperature on a thermostat or voltage on power management chips that keep electronics safe when plugged in. Embedded chips, TI's other major silicon product, are signal processors and microcontrollers for operating everyday devices, like telling the toaster to ding, the dishwasher to end a cycle, or anti-lock brakes to engage. TI sells the majority of its chips to industrial and automotive customers.
We tore down a Tesla Model 3, and to my surprise, they had among the most, if not the most, content of any chip supplier in the car.
That's the foundational nature of the products that we build. We have over 100,000 customers and about 80,000 different products. We say that if you have anything that plugs into the wall or has a battery in it or has a cord in it, you probably carry more than one TI chip in it.
Another pioneering moment came in 2009 when TI opened the world's first 300mm fab for analog chips, repurposing a memory fab after DRAM maker Kimanda went bankrupt in the financial crisis.
And people were like, wow, they're making this lagging edge technology on leading edge 300mm fab. But that's what really was the catalyst for TI to have such a cost advantage.
A 300mm wafer has about 2.3 times more chips in it versus a 200mm wafer, and you get tremendous cost efficiency.
Have other analog companies followed suit and now make on 300 millimeter compared to 200?
There are a few, I would say, but there are very few companies who design, develop the technology, and manufacture semiconductor, the whole value chain, that do it in 300 millimeter and at the scale that we do today.
TI's been closing and selling off some of its 200 millimeter fabs, making way for the 300 millimeter wafers that all 7 new fabs will pump out.
They win not because they have like 100% share of any one thing. It's that they are the one who, opens their jacket like, hey, I have this, I can offer you all this stuff, right? And like, nobody else can do that.
TI says it's the country's biggest analog and embedded semiconductor manufacturer. It sells tens of billions of chips each year, but they're cheap, especially compared to the CPUs and GPUs sold by giants like Nvidia.
Nvidia sells one GPU for $35,000, and they're selling a part for 40 cents.
TI's affordable chips do play critical supporting roles for AI. In a new partnership with Nvidia, for example, TI is developing a new type of chip to drive efficiency in power-hungry data centers.
The amount of chips that go around the GPU to power it, and the signal chain chips that go around it, there are quite a few of them in an AI system.
But in 2020, it was the auto and industrial industries that suffered when TI was hit hard by the chip shortage, unable to keep up with customer demand.
Everyone was like yelling and screaming about TI and saying, look, you're the poster child. I have to shut down my factory because I can't get your 40-cent part. TI's market share of analog industry revenue fell off a cliff. And their response has been, we're going to go out and we're going to build a bunch of factories. We're going to make sure that capacity is never going to cause us a problem.
Then came tariffs. In July, TI shares plunged over concerns about what tariffs mean for demand, although they have bounced back some since.
Is there a pull forward of demand, trying to get purchases in front of potential tariffs? And I do think we're seeing some of that. It's one reason I've been a little more lukewarm on the broader analog space.
But not everyone is concerned.
I would position them as more of a tariff winner than a tariff loser. If you're one of TI's competitors and you're using a foundry, let's say, and the foundry probably is in Taiwan, that chip is going to be more expensive than the same chip that TI will make because TI is making it in the US.
But despite its name and about 75% of CapEx here in the US, Texas Instruments is not only making chips domestically, it also makes chips at 4 fabs abroad, in Germany, Japan, and China, and does testing and assembly in Mexico, Taiwan, the Philippines, and Malaysia, where it's spending some $3 billion on 2 new sites, one of which is now in production. As for international sales, about 60% of revenue actually comes from customers based outside the US. China alone accounts for 20%, which exposes TI to geopolitical tensions and tariffs China is imposing on US goods.
They have some wafer fab capacity actually in China, so they can offset some of that.
Tariffs is a dynamic situation right now. Our global footprint and our manufacturing across 15 different sites provides us the position to be able to support our customers no matter where they are and in any political or economic environment.
In fact, going international was a real possibility when TI was selecting the site for this massive expansion. The decision came down to 2 very different options: Singapore and Sherman, Texas, a small city 60 miles north of Dallas.
We are the hub of the Silicon Prairie.
Sherman, with some 50,000 people, is also home to a global wafers factory. The Taiwan-based company makes those bare silicon wafers that chips, including TI's, are made on.
When choosing between doing this project overseas or here in this community, the independence that it gives this country and also the independence it gives Texas Instruments to have their products sourced here locally is huge.
Sean Tiemann became mayor in November. His family landed in the area 2 generations ago when his grandfather worked alongside Jack Kilby at TI.
He holds 78 patents in the semiconductor industry.
And this isn't TI's first time making chips in Sherman. It built a 150-millimeter fab here in 1966. When TI announced plans to close it in 2020, the local government worked on incentives to entice TI to stay.
We were able to offset some of their tax liabilities and also help them with some water rate discounts.
Now Highway 75's been expanded, downtown has new businesses, summer concerts, and a growing population. As for federal support, TI got $1.6 billion of CHIPS Act funding, plus a whopping 35% investment tax credit. That's an increase within Trump's big bill for those breaking ground on fabs before the end of 2026. At the state level, Governor Greg Abbott has long offered incentives to chip companies willing to build here, from low taxes to the $1.4 billion Texas CHIPS Act passed in 2023.
Because we have ports, because we have access to materials, because of our low cost of doing business, we're best situated to lead this next generation of chip manufacturing.
Samsung is the other chip giant in Texas since 1996. It's building a $17 billion advanced chip fab near Austin, where Apple, Amazon, and AMD design many of their chips. Other chip makers in Texas include Infineon, NXP, XFab, Micron, Global Foundries, and tool supplier Applied Materials. But why Sherman?
We have the resources like water and electricity here locally that most cities don't have across Texas or anywhere else, really.
Indeed, making chips takes a lot of power and water, and both have a history of being scarce in Texas.
The semiconductor industry here in our community, and largely driven by Texas Instruments, almost doubles the amount of water that our city was using.
When this factory is fully built out, we would use about 1,700 gallons per minute.
TI's immediate target is to recycle at least 50% of that.
And potentially achieve up to 80% water recycled rate in this facility.
Texas is hot, with about a quarter of the state in drought. But in Sherman, there's Lake Texoma.
We treat our own water, we pull it from Lake Texoma, and we have water rights, which most communities don't have.
Chip manufacturing is also a power-hungry process.
By some estimates, we're going to run out of power by 2030. What's your plan?
This 300 millimeter manufacturing actually drives in energy efficiency. You use pretty much the same amount of energy, but produce 2.3x more chip. But also, I'm really proud to say that this factory, when it's in production, 100% of the energy is renewable.
Texas's uniquely independent grid largely cuts it off from borrowing power across state lines. In 2021, that grid failed during an extreme winter storm, causing at least 57 deaths, and halting production at chip makers like Samsung and NXP, although TI says it maintained critical operations.
We built redundancy into this facility. We have multiple transmission lines that feed power into the site. We also have large diesel storage tanks and generators that can continue to power the site for a few days.
It also helps that Sherman has a power plant in town, which recently increased capacity. Highly skilled chip engineers are another scarce resource, a talent pipeline that's been stymied by the dramatic decline of U.S. global semiconductor manufacturing share over the last 3 decades.
Analog engineers are pretty sparse to begin with, so there's a lot of younger people moving to the area. I actually think it's going to be easier for them to get the talent now than it would have been 5 to 10 years ago.
With the full $60 billion project, TI says it will create 60,000 U.S. jobs.
We partner with universities to develop engineers, but we also partner with the military, with skilled workforce development to develop the right kind of talent that we need as we continue to grow here.
As for whether this massive increase in CapEx is too much,
they're making a big bet on the fact that they regain share and that demand comes rocketing back. If you don't regain that share, it's hard to justify building this much capacity.
Back in Sherman, we got a sneak peek into the shell of SM2.
And then long term, all 4 factories on this site will be connected together with one clean room, one overhead track.
TI wouldn't divulge a target completion date, but it does plan to make a lot more chips on U.S. soil one day.
Can you share anything specific about timing?
No, it's hard to predict when exactly that will take off. We're hopeful that we'll continue to build out at a pretty brisk pace, but it really depends on the market.
This is the iPhone Air. It was the big star of the new lineup unveiled by Apple in September. At just 5.6 millimeters, it is the thinnest iPhone ever, with a nifty flexible new front camera and the ability to dual record from the front and back simultaneously. They're features shared by the 17 Pro, plus some new AI features, all powered by a more hidden star, Apple Custom Silicon.
A19 Pro is going to be around here, just near the top side of the vapor chamber.
Apple's most advanced chip yet, the brand new A19 Pro, is inside both the Air and the 17 Pro, and I got a rare chance to see inside the 17 Pro for a peek at the new chip at the big unveiling. A major change, Apple's put neural accelerators inside the 6 GPU cores to help power AI on device.
We've given software developers tools across all our major compute platforms now to build AI in naturally to every application. The integration of that neural processing is reaching MacBook Pro class performance inside an iPhone.
The Air also has a new Apple-designed modem, C1X, and Apple's first wireless chip in iPhone, N1. Is this Apple moving towards controlling the full stack of silicon inside the phones?
Yes, and actually truly being able to design and optimize a solution for what that given product needs.
And really, I think that's where the magic is. When we have control, we are able to do things beyond what we can do by buying a merchant silicon part.
All this comes as Wall Street is putting pressure on Apple about their AI strategy.
This part really comes down to how far they can go on their own in AI, right? They're not OpenAI, they're not Google. They probably won't ever have their own Apple model like Google or OpenAI. They're still gonna run those services on iPhone, right? They want the iPhone to be the best place for developers to run their AI.
Now we're at Apple headquarters in Cupertino, California for the first ever US interviews about what's powering the new iPhone lineup, custom chips.
The Air is Apple's first major new iPhone design since 2017. So why did the company's stock dip on the big reveal, although it has recovered in the days since?
This is a really tough moment for Apple because the company's got this difficult headwind that people want to hear more, see more about AI, waiting to hear a bit more about Apple Intelligence.
What do you say to those on Wall Street who are concerned about your AI strategy?
I think for what we're doing with iPhone, I think we are building the best on-device AI capability that anyone else has.
Behind the Air's enhanced durability ceramic shield, within the new raised plateau that houses the 48-megapixel camera, there is news about AI. Apple's implemented a new chip architecture to prioritize it.
You're integrating neural accelerators into each GPU core. How exactly does that work?
The GPU is actually a collection of tiny little processors, all running in parallel. With this year's GPU and the A19 Pro, we're integrating neural processing in a way that allows someone who's writing a program to one of those small processors, extending the instruction sets, and they can switch back and forth between 3D rendering instructions and neural processing instructions, all seamlessly inside the same microprogram. And so when you look inside the neural engine, for example, you have a lot of dense matrix math. We didn't have that capability on GPU, but now we do with A19 Pro.
Apple's original AI hardware, its Neural Engine, was first unveiled back in 2017. The Neural Engine was barely mentioned at the launch. Instead, it's all about adding compute power to the GPUs with those neural accelerators.
They're essentially just additional cores that have a specific design, in this case, very similar to a tensor core or like a tensor core to run those transformer engines, that matrix multiplication math. But putting that in the GPU actually makes it a little bit more like some of the things like Nvidia does in cloud processors and some of the things that other silicon vendors do for AI.
Now, our GPU gives us the ability to apply neural processing across applications that are traditionally more graphics-based. For example, gaming applications, using AI to enhance the quality of the imaging as well as to improve the efficiency of some of the image rendering. And so by placing it there, we've given them a tool where using the neural engine was maybe a little bit harder. Now they've got it built right into the engine they're already using.
Do you think the A19 Pro should signal to investors that Apple does have it together when it comes to AI strategy?
Yeah, I mean, I think just the GPU architecture, because that neural accelerator comes on all of the chips, right, all the way down to the entry-level iPhone 17. I think that's showing you that they're making compute and architectural changes for AI, both on device and then obviously things I believe, that they'll do in hybrid cloud.
Through our extension to private cloud compute, we have a very great story that's evolving over time. But right now, we are focused on making sure that these phones that we're shipping today will be capable of all the important on-device AI workloads that are coming.
Why is on-device AI so important?
We've talked a lot about this. Privacy is a big deal. We know that when we can do things on-device, we are able to manage people's privacy in the best way. The other thing about it is, it is efficient for us, it is responsive. We know that we are much more in control over the experience.
In the Air, the A19 Pro is housed in the new raised plateau on the back.
And so this design of this also helps with thermal dissipation, but also it gives as much room as possible on this side of the surface area to maximize for battery life.
Following overheating issues in the iPhone 15, a new vapor chamber in the Pro models keeps the custom chips cool.
We think about how that all goes together, including with that forged unibody aluminum design, which is incredibly thermally conductive, so that we can effectively dissipate heat with the vapor chamber, with where it's positioned with our chip, and it's even laser welded into it, which creates a metallic bond, which also helps dissipate heat.
And the A19 Pro wasn't the only new chip Apple unveiled.
Introducing N1, our Apple-designed chip, which enables the latest wireless networking technologies.
Apple announced its first in-house wireless and Bluetooth chip for all new iPhones, and an updated Apple modem for iPhone Air, nudging out Broadcom and Qualcomm chips.
Would it be fair to say that Apple now controls all of the core chips in its own phone?
Yes, 100%.
Apple has been making its own networking chips for AirPods and Apple Watch for nearly a decade.
We are able to co-design our SoC, A19 Pro, with N1 to build power management capabilities that allow us to keep the application processor, the big SoC A19 Pro, mostly asleep while the wireless is running, but quietly we can build in co-designed interfaces into that N1 that allow us to do processing on the SoC at extremely low energy for background tasks. So we can be, for example, allowing the device to sort of track location with high accuracy so that your device can actually be more intelligent about where you are.
Yeah, one of the things people may not realize is that your Wi-Fi access points actually contribute to the device's awareness of location. So you don't need to use GPS, which actually is costs more from a power perspective.
Until now, Broadcom was the main supplier of wireless chips in iPhones. Broadcom's stock fell slightly on the N1 news, but bounced back quickly. Apple does still have a licensing deal with Broadcom for its technology. N1 is in the entire 17 lineup and iPhone Air.
Will we see wireless and Bluetooth chips in all Apple devices?
General focus is on building the right solution for a given product, but yes, you could expect to see that.
Did this indicate a sea change toward Apple trying to control the full silicon stack?
Absolutely. I mean, I think this has been their goal from day one, which is anywhere that they can make a custom chip, or that they need to make a custom chip because it improves the experience, which I think is really the example you see with their modem.
That new Apple modem, C1X, is in the air. Its first iPhone modem, C1, came out in February in the 16E.
Over the last 6 months, we've really driven a significant performance boost on C1, such that now it's twice as fast in terms of speed. And at the same time, we actually drove an energy efficiency even further. So for the same use case, C1X now uses 30% less energy if you compare it to the modem that's in iPhone 16 Pro.
That modem in the 16 Pro, it's made by Qualcomm.
Their whole proposition there is we can do this at lower, power. It may not be as good as Qualcomm's yet, right, in terms of just overall throughput and performance, but they can control it and they can make it run at lower, power. So you're going to get better battery life. And obviously, controlling the modem makes a sense when you want to miniaturize things, right? So if we think about where my glasses might go, right, other form factors that are super small, they need to control that stack.
Qualcomm stock wasn't much impacted by the news, having long warned investors of the coming change.
We've known it's a long time coming. It was just a matter of when. And then when does it go across the portfolio, right? That was the biggest question. And I think you're just seeing, right, that pace to be the next couple of years to completely phase them out. But I do think it's a testament to it's not on the Pro because Qualcomm still makes the best modems.
And why not see an Apple modem inside the iPhone 17 or the 17 Pro or Pro Max?
Well, we were really focused on what we needed for iPhone Air. And we have great products with iPhone 17 and iPhone 17 Pro as well. And over time, we'll see Apple cellular solutions in more products.
Like with Broadcom, Apple will continue its licensing deals to use some of Qualcomm's core technology.
Does the C1X, Apple making its own modems for phones, signal trouble for Qualcomm?
No, I don't think so. I mean, again, I think they're still the gold standard for modems. What they do with the Snapdragon line is still pervasive across the vast majority of high-end Android smartphones.
Apple does still rely on others for smaller key components, like Samsung for memory and Texas Instruments for analog. But the core chips?
How long do you think it'll be until we see every iPhone with Apple-designed modems, Apple-designed wireless and Bluetooth chips?
I think there's a good chance by next year, but for sure in the next 2 years. And all devices, right? So we expect that there would be modems coming to Mac. We would expect there's modems coming to iPad. So I think over the course of the next few years, it will be on all of the portfolio.
Are we going to see neural accelerators in the GPU cores of the M5, for instance, and on other devices?
We have a unified approach to architecture. My group, when we architect our GPUs, we're looking across the full set of chips. We like to say that our generational improvements in GPU and the features that we put in them, we extend them across products as appropriate. So
probably.
As for where Apple will make so many custom chips, the A19 Pro is at the leading edge of Taiwan Semiconductor Manufacturing Company's 3nm node. At its new campus in Arizona, where we got a tour, TSMC is working toward 3nm production by 2028, but it's not there yet.
But if you need to be on the leading edge, it's going to be Taiwan for the time being.
Have you seen signals that Apple is concerned about that and trying to change it?
I think everybody is concerned about this because there's really a question of what part of tariffs impact the silicon supply chain, right? And I think this is obviously why, Apple and Tim Cook are on their mission and out there talking about investing in America.
Also geopolitics, relying entirely on Taiwan, does that pose risk for Apple?
It does, as we're accelerating toward wanting to use the best process node available that will still be in Taiwan until Intel becomes a viable option. So that's, I think, really the challenge is that's going to be a while, at least, right? The next 2 to 3 years.
How likely is it that Apple will start making some chips with Intel in the next few years?
I think there will be serious consideration if 14A really does deliver on all of its promises.
In August, Apple increased its commitment to manufacture in the U.S., amidst Trump's new promise of a 100% tariff on chips from companies not making domestically.
Apple is leading the creation of an end-to-end silicon supply chain right here in America.
TSMC is ramping to 3nm in Arizona. I've been there. They aren't there yet, so right now I presume these will be made in Taiwan. What is the goal as far as manufacturing in the US down the road?
I think we are super excited about TSMC's push into US manufacturing. Obviously it will help us from a time zone perspective, and we also appreciate that the diversity of the supply is also really important.
$600 billion being spent in the US over the next 4 years. Do you know how much of that is going toward custom silicon?
I hope it's a lot.